much about what they were doing with that, except there were four modulations of different frequencies for the AM modulation, because it was not FM, for the antenna system. And this antenna system also required 4 RF transmitters, which were operating in conjunction with the preceding driving electronics, which produced a quadrature type of field, which was a rotating electric field set up in a quadrature antenna, which means there were 4 transmitting lobes, 4 transmitters driving it, with the associated electronics, which would produce a rotating electric field at a very low rate. As I remember now, the electric field was rotating at pi radians per second, which says 1/2 hertz. Frequency, which is to say it would take 2 seconds for the electric field to do a full 360 rotation. The magnetic field was rotating at half that frequency, pi over 2 radians per second. And the modulations on the magnetic fields were somewhat different. They also used 4 coils, so that because of the way the coils were configured and the driving was configured for the 2 generators, they could produce a quadrature field, a rotating magnetic field. The modulations award determined the fact that you interlocked the electric field and the magnetic field in a certain manner, so that by generating those 2 artificially, you locked in with the gravity field.
Physically, how large was this equipment that was on the ship?
In terms of which? The battleship, or in terms of the...
On the battleship, yeah. Was it quite significant?
Covered most of the forward deck.
Most of the forward deck?
Yes.
What about the back?
Nothing on the back deck.
It was just all on the forward deck?
It's all on the forward deck, and of course you had to put an antenna on the up top, the highest mast, and they had to have 4 coils which were arranged symmetrically around the high antenna.
How large were these coils physically?
They were essentially the same coils that they used later on the Eldridge. They stood about 7 feet high. They were wound as a single turn coil, copper tubing, about 1 3/4 inches in diameter, hollow, liquid cooled, because we were pumping enormous amounts of power through them. And the interesting part about this coil, it was tapered as a conical coil. See, Tesla had a very strange quirk in a lot of things. He liked to design transformers even, which were wound not the way we do them today, but tapered, a sort of a tapered conical coil. He said they were more efficient, and I believe there is mathematics today to back that up. But the coil on the deck was conically wound, so it was perhaps not more than a turn that size at the top, let's say about 6 inches. When it got down to the bottom, the single turn, if you will, which is a spiral, was about 3, if I remember correctly, about 3.5 feet broad, and had 1 feed connection on the bottom end and 1 feed connection on the top through the center. And of course there were 4 of these coils. So I remember counterclockwise wound, depends on your reference point of course, and of course they were fed individually by 4 sets of cables. So those coils were quite large, and eventually because he used analog, this is another interesting fine engineering point, analog driving, there was no ringing problem, so there was no ringing dampening required on those coils. When it was switched to the Von Neumann approach later, they had to put damping or anti-ringing coils on the top of the coils, which were literally bodily moved over to the Eldridge. They used the same coils. But the generators they used, as I recall, all that stuff was mounted on the decks of the battleship. Some of it was on the dock side. If I remember right, they had a diesel electric generator. That was dock side. The large generators, I'm not even sure how they arranged those now, because it was not the same configuration as they later used on the Eldridge. The Eldridge were able to design the ship for everything being built in the interior. But they had the 2 large generators. They somehow managed to synchronize them. At least they claimed they did. We never really proved whether they were synchronized or not, because the whole test was sabotaged. In the new approach, Von Neumann wanted to use a digital, if I may borrow that term, a pulsed approach would be the more correct approach. but the more correct terminology, in which he had a 10% duty cycle, 10% on, 90% off, and he wanted to pulse it with very high power. He increased the size of the transmitters from approximately a half a megawatt output each of the RF variety, that is 4 of them at half a megawatt, to 4 of them at about 2 megawatts output, operating in essentially the same frequencies, 160 megahertz region, and of course the modulation on that. Now I raised the question, remember this, I didn't think it was possible to generate that amount of power in the period around 1942-43 with the equipment then available. Well, it turns out, doing some research, as I ran across a book on the early radar systems for the Navy, they were generating tens of kilowatts and up to 100 kilowatts at frequencies up to 300 and 400 megahertz in 1940-41. The equipment existed, but it was not available to the civilian sector, I'll put it that way. What they built for the military was always years ahead of what the civilian sector gets, and that held true for this. The magnetic aspects, of course, was quite standard, except the generators they finally built for the Eldridge, or DE-173 as it was known before they dubbed the name on it, were quite special in design. Each had 5 field coils. That's rather odd, and I don't know why von Neumann chose to have 5 field coils, and they had 2 generators, which had to be driven by the same motor set, not generator set, they were the generators. 750 horsepower electric motor, huge gear boxes, right angle drive. They mounted the generators vertically, that is the shafts were vertical. Shafts were about 8 inches in diameter, which they were monsters. The things were very heavy. They wanted the mass in there, the mass inertia, because you can pull out of that mass inertia enormous amounts of stored energy. And when they were pulsing the system the way he was, you had to use the mass inertia storage to get the additional electrical power out over the actual readings, which were 75 kVA each. So it became a very complex and interesting system. The 5 field coils on each one, 10 total field coils, were driven with vacuum tubes.
Now, was all the equipment on the Eldridge on the front of the ship as it was on the other
No,
ship?
everything for the Eldridge was built underneath, below deck,
right.
Designed that way because what they did with the Eldridge, or shall I say DE-173, the one that was built for these tests was built in the Brooklyn Navy Yard, well ahead of the one of record, which is in the official Navy records, the 173 DE-173 named Eldridge, which was launched in July 43 and commissioned on September 27th or 28th of 43. That's the official record for the official Eldridge. The unofficial Eldridge, the one they used in these tests, was given the same number and the same name, was built during the summer of 1942, that is the hull, in the summer of 1942 at the Brooklyn Navy Yard, was, when the hull was finished, was launched about September of 42, moved to the Philadelphia Navy Yard, was towed over, put in dry dock, and they finished all of the rest of the work in dry dock, which meant all of the heavy interior machinery, drive systems, the ship's electric generator systems, a special diesel electric generator for this system, which was 8 megawatts, quite a big monster. They couldn't put that on deck.
So nothing was on deck during the
Nothing was on deck for the new ship.
Normal ship.
It was like appear to be and look like a normal ship. And this is the way they wanted to build them, but of course this was the first one and the first of the series they hoped. So between September of 1942 and December of 1942, virtually all the heavy equipment went into the DE-173. It was still in dry dock. And they had all the heavy stuff in that they need to put in the ship, including all the normal drive systems and all the normal hardware, all of the ammo stacks, the guns, etc., except for turret number 2. That remained a dummy. There was a hole there, and they put a dummy turret on it later. When they got all the heavy stuff in, they took it out of dry dock, towed it over to the section in the back where they put in the rest of the electronics. That went on from January of 43 up through the period of June 43. Now, as Duncan and I had been selected, if you will, for these tests and for the whole project. Von Neumann decided during the summer of 1942 that what we really need, and the Navy fully agreed with him, is a specially selected test crew to be on this ship for these tests. Specially cleared, special aptitudes, etc., etc. They went throughout the whole Navy for over 3 months to get candidates they could select when they were properly selected, which included physiological testing and apparently genetic testing. For what reason, I don't know. They went through a 90-day school also, which my father, and then, of course, during World War II, working as a volunteer for the Coast Guard, trained him in a Coast Guard facility. When that was done, there were pictures made of the graduating class, some 33 of them, and they were moved to the Philadelphia Navy Yard.
Now, you have this picture on the CD, correct?
Yes, I have it.
Okay.
And I'm going to take a trip.
Okay, we're starting with the second part of our Philadelphia experiment, and I think a good place to start is to describe who you knew some of the manufacturers of the equipment were.
Okay. Since originally it was a Tesla project, one has to look a little bit at the background of Tesla in order to understand why he leaned rather heavily towards Westinghouse for all of the generators and motors and such. If you go back a little bit in his history, of course, it was George Westinghouse that first set him up in terms of the patents that Tesla had for the AC motors and generators, which Westinghouse built. Westinghouse held the 20 patents and, of course, paid huge royalties to Tesla until Tesla tore up the agreement to save Mr. Westinghouse's neck. So he always had a strong, favorable leaning towards Westinghouse and Westinghouse equipment. On the other hand, GE he would have nothing to do with, because GE was always backing Mr. Thomas Edison, and of course he had a very nasty run with Thomas Edison as one of his employers when he first came to the United States. Edison welched on an agreement to pay him $50,000 bonus if he would finish a project in time, and that project happened to be stopping the arcing of brushes in DC motors, which Edison was building then through various organizations. Edison did do quite a bit of manufacturing himself at first, but then later on became strictly the inventor and having other people do all the work. But because of that incident, he wanted nothing to do with Edison or anything that Edison was connected with, so GE was out of the picture. Now, as time went on, of course, Tesla was out of it. Von Neumann was not about to change horses in midstream, because Westinghouse certainly built good equipment. They were building very excellent equipment, and they were already supplying some of the equipment for the project. Now, insofar as the transmitters were concerned, FTR, or Federal Telephone as it was known then, and later on became known as Federal Telephone and Radio after World War II, was quite a large supplier of radio transmitters for a number of years, both for the military and commercial. They're not known under that name anymore today. I'm not sure where they fall into in the current realm of transmitting equipment, and whether they're even in business anymore as such, or whether they've folded and were totally absorbed. But that was the preference and choice of Tesla at that time, and of course Von Neumann followed along with it because he wasn't about, with the pressure that was on him to get equipment built and tested, to change to another supplier in midstream and start the whole process all over again, because it doesn't make sense when you're on a tight schedule. So that was some of the names of the equipment that were involved there, and so far as winding coils and some of those other things are concerned, I think a lot of that stuff was done right in the shops of the Navy. The antenna system could have been built by FTR, could have been built in the Navy yards for that matter, because they did have manufacturing facilities. And at that point with the antenna system, excuse me, one of the other people who was involved in designing the antenna system after Tesla was out of it, as well as during the time he was in it. And a number of other consultants came in, became part of the project in one way or another, and the total number of personnel kept going up, because the aspect they considered was how fast can you get it done, or more people get it done quicker. Sometimes